All right, on to session number 3, which is the Rados Gateway new multi-site configuration. So I guess start with a rundown of the blueprint, and we'll dive in.
Yeah, no, we are now on the configuration was the second part. Now we're not talking about the sync. We switched the topic actually. All right, so right, so in the previous topic we were talking about the configuration and all the changes that we are making in order to make the configuration much simpler, and we're gonna have all the needed data and information we're gonna need for doing the multi-site sync. Now this includes the new realm that is basically not really meaningful. You can look at currently the current system as a single realm, but you'll be able to create multiple realms. But that isn't really the interesting part. But a more interesting part is having the new period, which allows us to make sure that when switching master zones, we are not going to lose metadata information. So, and how that's going to work. So let me just talk about how actually the sync is going to work, and we see from there. So it's not that much different from the previous scheme, but there are some significant changes. First of all, the previous scheme dealt with separate metadata syncing and separate data sync, and that's not really going to change. So it's still going to be separate operations for the different sync processes. So on the master zone of the master region, you're going to do all the metadata changes in metadata operations. These are going to be logged into the metadata log. And this is still going to happen. What we will be doing is, though, in the slave zones, and when I say slave, I'm talking about slave with regard to metadata. The slave zones, instead of directly applying the changes, as we were doing before, what we're gonna do is we're gonna fetch the metadata log information from the master and apply it on the specific zone, on each zone, which means that we're gonna create a replica of the master zone metadata log in each zone. And then, only then are we gonna really apply these changes on each zone. So basically, in each zone, we're gonna keep a replica of the master zone's metadata log. That's one change. And the reasoning behind it is that beforehand, what happened was that when we were doing, we were just directly applying everything, we only had one copy of the metadata log. And so if we needed to switch around the masters, we were out of sync, and all the versioning was clobbered. So we're going to do that. The second thing is for each metadata entry that we're going to apply, we're going to keep it on two different objects. One would be the immutable object represented by the metadata entry and by its version. And second entry that includes, that is basically the metadata key that we currently hold. So, for example, if we're gonna sync a new user, then each metadata entry already holds a version, internal version, but we end up creating an object, and the object name is the UID. So that's what we're currently doing. So now, instead of that, we're going to have two different entries. One would be the UID column, the version of the UID, and the second entry would be the actual UID. Now, when you read, in regular operation, when we need to read the UID, we're just going to the UID object. But when dealing with syncing of metadata between zones, we're going to actually access the versioned UID object. So now, we have that. Now, the second thing that we're gonna do is in each period, we're gonna keep a vector of the metadata version. Now, I'm saying a vector because there is more than one metadata log. A metadata log is sharded, so you can have 100 different objects that are gonna keep metadata log entries. So each period is gonna keep the information about when the period started with regard to the metadata log version. When we switch a period, we create a new period, and the new period, usually when we switch it, it's when we switch to a different region or a different zone group, and we're going to keep a version of the metadata log on that when we actually switched it. Now, that version vector might reflect where the new master is located within the previous master, and it might miss some entries because the old master didn't sync all the data, so it didn't fetch all the data from the old master, and the old master crashed, and now we needed to switch to a new master. So it might hold might not point at the latest. When we are gonna now sync against it, when we do all the syncing, all the zone groups are gonna look at that information, because now a new period happened, and they need to make sure that they're pointing at the exact version that the period is positioned at. So they're gonna, if on a specific metadata log shard they're ahead of where the period is, they're gonna need to roll back to the previous version, or to the point where it needs to be. So that's why we have introduced all the period information to start with, so that we can handle that. Okay, that's with regard to metadata sync. Now, when we introduce or create a new zone group, we're gonna still do the same full sync of metadata, but one option to do it is to make sure that, for example, we have only one zone that does it. We can have multiple ways to do it. For example, one zone within the zone group to fetch, to ask from the master and tell it, just give me everything you have. That might be at this point the most efficient way to do it. Or another way to do it is to shard that information and ask it to give it all that it has, but in a shard way. So that give me shard 1, give me shard 2, give me shard 100. Whereas at the moment, what we have is the current scheme is the destination needs to list all the entries and then go one by one, which works, but it's not very efficient. So I'm thinking that it'll be probably easier to just, when setting up a new zone, to just ask for everything and get it in one big chunk from the master. But then it depends on how much data is there. So it might be better to shard it. So that's about metadata. Now, moving to actual data. So we discussed the notion of having an active before, and but let me actually talk about something else before that. We in our current scheme, we have all the logs, all the three logs, metadata, change buckets, and the bucket index log. And then we have a sync agent that goes over the logs and synchronizes everything. Our aim is to kill the sync agent and to push all the stuff that it does into the gateway. And that's because we think it's going to be more efficient to have it in the gateway, than it's going to simplify configuration and everything. So that's one thing major that's going to happen. We're basically going to re-implement the sync agent within the gateways. So that's one. The second thing is, now we're gonna have an active scheme that we discussed before, and the idea was to do it within the sync agent, but now we're gonna do it within the gateways themselves. And that's gonna happen, still happen using the same logs, just that now instead of each zone following its master within the same zone group, as we said before, each zone can be connected to multiple zones. And it's still gonna read the change buckets log, and still gonna read the bucket index logs from the remote one. But there are gonna be multiple remotes. So it's gonna read that the information from this same for example, for the same bucket from two different zones. And it's gonna need to apply all changes that happen on both. Now, obviously, if there are changes on the same object, there's gonna be some kind of tiebreaker. Since the gateway itself deals with objects that cannot really be partially modified, we don't have a big issue of who's gonna win, or we don't need to merge changes. We just need to have one winner for a change, and the tiebreaker that we think would make more sense is by looking at modification time of the objects, which is as good as any other scheme that we could think of. So basically, if we're gonna go over a bucket index log, we start gonna apply the changes. See, oh, there's a change on bucket foo object bar. We're gonna apply it internally. We're gonna fetch the object bar, and then we're gonna go to the other zone and see, oh, there was a change on bucket foo object bar. We're only gonna apply it if the object has a newer modification time than what we have, and we already have that ability to be able to do that, to only apply changes that have that have newer M time. There still is the edge case where the changes have the same M time, and there is going to be some kind of tiebreaker based on zone ID or zone name. That's about it. So that's active. Now, let's see if I'm missing anything. Okay, so talking about the sync agent a bit more. Some of the issues that we're having with the sync agent is the inherent two-stage sync process, in which you first do a full sync and then you do incremental sync, that's more of the implementation. But the problem with that is that we were having trouble. What happens if there were failures during the full sync? For example, a bucket wasn't we were getting errors during during a bucket sync. There wasn't any way for us to recover from that. So we weren't really keeping, or moreover, that could hold the entire sync process, because if we need to start doing incremental sync, but you're waiting for that one bucket to finish the full sync, you're holding all the changes that were needed to go to the incremental sync. Another thing was also mainly related to the way to the implementation, but the way we went over the shards was we going by sequences, like go over the shard, over the different log shards, and applying each log shard independently, but then you might have one bucket that had lots of changes and was dominating all the process, and in the meantime was holding all the other changes to come in, because we were stuck on that one. And you need to apply changes within each shard in order. So that's another issue that we were facing. I think that, I know that in the new implementation, we need to take care of that by first of all, not looking at the process as a two-stage process, but rather make it one stage with different states. So, and a bucket could be in either a full sync state or incremental state, but it only applies to that specific bucket. Some of the issues that we were seeing before that were related to the way the sync agent is a third party, basically. It's telling the zone, go fetch data from the other zone. Some of the issues were related to that, because the sync agent might time out, or the operation might break. And there was specific issues that could lead to that. For example, a copy operation can take a long time. And in the meantime, the zones, Apache on the zones would time out, say, didn't get any data, I'm doing 5 gigs object copy. So, here's a 500 response. No, we were able to follow up on that, and we were mitigating that, but still, it added more complexity. And now, since we're going to run on the zone itself, we're not going to have that specific issue. So that's about it. Trying to see if I was missing anything important. Yeah. Oh, yeah. One other thing, we want to reduce the time it takes for changes to propagate to the different zones that follow. And beside the current pull scheme, we're gonna add push notifications. Basically, you have a zone following another zone. So the other zone is gonna tell that zone about all the recent changes that happen immediately when they happen. There are gonna be some RESTful API to facilitate that. But that's gonna be on top of the regular pull operation, so that if for some reason they miss that notification, then they're still gonna handle everything doing pulls. So that's about it. Yep, I think, right. Any questions? Trying to be as coherent as I can, but but it's kind of complicated, and there are lots of stuff that can be addressed there. So
Cool. So we have one more, right?
yeah, I don't know if we have Radoslav around. Probably not. So, but we can talk about it.
All right, let me switch over here.